greetings. One of the things we do in evaluating civilizations is to, as far as their mathematical sophistication, is to ask, what did they know about pi? And we're not talking pizza pie and we're not talking apple pie, but the constant pi, the ratio of a circle's circumference to its diameter. Well, the Egyptians had a pretty good system, but let's talk about just how sophisticated they are. Now, some of you may have watched various programs on television where someone will espouse the theory that the Egyptians had some great knowledge of pi to some outlandish number of decimal places because of the precision with which they built the Great Pyramids. Unfortunately, that's all bunkum. They didn't understand pi, and here's the proof that we have. It's in the Rhine Papyrus. How do you calculate the area of a circle? So let's take a look at this. If you have a circle, and in the Rhine Papyrus, the problem says the diameter will be 9. And the unit of measurement is a ket. I have no idea how long a ket is, but I know it's going to be 9 of them to give me the diameter. And then the Egyptians said, we're going to find the area of this circle. Now for us, in our modern way of thinking about it, we know what to do. Area of a circle is the pi times radius squared. So for us, we would simply take the value of pi times 9 divided by 2 and square this. And from that, we're going to get an answer of 81 pi divided by 4 kets squared is the area of that circle. Now, the Egyptians give us a number for this, and we can come up with a number for this as well. Now, by comparing the Egyptian area to the area that we would calculate, we can come up with what is their value of pi, because we know what the correct answer should be. And this will give us some idea of what they were using for this mysterious number. So, let's see what we come up with. Well, for us, we could use this as several different numbers, 3.14 being probably the one you're most familiar with. And so, for that, we'll take a look. What I am going to do, though, is I'm going to use 22 over 7, because that is an approximation that is used when dealing with fractions for pi. Matter of fact, before the calculator age, that was the standard approximation for pi that was used. So for us, I'm going to have a fraction over 28, and if you'll permit me, I'm going to have 81 times 22. So I'm going to have 16 and 2, and 16 and 2, 2871. So 1782, and this is in ket squared. So for us, this is our calculation. We know what the true answer is with a reasonable degree of accuracy. If you need to, please pause the video now, get a calculator, see if you agree that I have got a reasonable estimation for the area of this circle. And let's wait to see what the Egyptians do. And now, a little bit more about the area of a circle and the Egyptians. One is, by one of the problems, we're going to find the area of a circle. And here's the problem from the Rhine Papyrus. And the Rhine Papyrus, and I believe it is problem number 50. Problem number 50 from the Rhine Papyrus. Find the area of a circle that has a diameter of 9 ket. So I've given us a ket. A ket is this long right here. And I have made this circle to have a radius of 4.5 of those guys. And that, we'll see what this means. Now, a little bit more information about the kit. I have no idea how long it was. I just have to come up with something for the demonstration. Now, let's take a look at what we're going to do here. And I'm going to move my circle out of the way. And I will move my measurement with it. Now then, what we now want to do is talk about how the Egyptians would find the area of this particular circle. This is the only example we have, and so this is going to give us a methodology that they would use. And their methodology would be step 1. They were smart enough to know that any circle can fit snugly within inside of a square. When I say snugly, I mean it hits the square at all 4 sides. And so because of that, there's no smaller square that can contain that circle. Now, once you contain it in that circle, now what you wanted to do was step 2. They cut the square into 9 smaller squares. They basically took 1/3 of each side. And for their example in the Rhind Papyrus, it's probably why they chose 9 ket as one of their measurements, because 9 is divisible by 3 very easily, giving me squares that all measure 3 by 3. Now then, once they did that, they came along and said, now let's take a look. And here's the brilliance of the Egyptians. They said, all right, we notice that, and let me back up and show you and point it out. This circle fills up a lot of those squares, 5 of them. We have the 3 coming down the center and the 3 going center across, or more or less all included in this area. So that would be a 3 by 3 square, and I have 5 of those. So 3 times 3 is 9 times 5. That's 45 ket squared. But then the Egyptians would ask the question, well, what about the 4 corner pieces? And what they said was, don't worry about them. They're very, very close to being triangles. And because they're close to being triangles, we're going to ignore the bits and pieces that don't quite fit. And so we're going to have 4 half squares or 2 more full squares. So I have 3 by 3 twice more. Well, 9 times 2 is 18. And we're going to call this the area of that circle. Now, let's take a look. So there's the area that we get from the circle. I just put it here at 18 ket. Now then, we also have this bit of information here. The Egyptian method for finding this is going to give me an area that I can now look at. And this is all based upon kets, and so I see I get an area of 63 kets, if I'm not mistaken, in total. And this is kets squared. So the Egyptians say, hey, 63 ket square, area of the circle. Now, anywhere in here did they ever use the number pi? And the answer is no. Why? The Egyptians didn't have any clue about the number pi. I don't care what the people on Ancient Aliens say. They didn't know pi. Now then, let's come down here and let's put one more bit of information up here. And this piece of information is now telling us some more about it. We know that we have some values here, and we know that error is basically saying take the truth minus experimental divided by the truth and multiply it by 100. And we want to take a look at, we know what the real area of the circle is, and that would be given by the formula area of a circle is pi times r squared. So we would take our understanding of pi and we would multiply it by 4.5 ket, and we would square that. And then we get a number in a decimal representation. So I have truth, I have what the Egyptians came up with, and with that I can now talk about the amount of error that the Egyptians have. And this error is given as a percentage. about 1% error for this particular example. So were the Egyptians really super sophisticated? Answer, no. They didn't have pi. They did a lot of things right. They did a lot of things we now know absolutely wrong. But for this example of their knowledge, they're down to 1% by basically taking a problem they cannot work and turning it into a problem they figure out they can work. Dividing a circle into 9, put it inside of a square, and make that square 9 smaller squares. They can sneak up on this. Now, likewise, if we want to think about the Egyptian knowledge of pi, and we know that area is equal to pi times r squared, well, we can also say, well, the Egyptians got 63. There is some Egyptian value for pi that we could calculate. And so Egyptian pi is 63 divided by 4.5 squared. And so approximately that is their value for pi. Get a calculator, multiply that out, and compare it to our value of pi. And you can use your pi key on the calculator, 3.1415, etc. And you can see, did they have a real good value for pi by doing the problem this way? And the answer is, it's close. And that's the best we're going to do for a long time anyway, because it's going to take us all the way to Sir Isaac Newton in the 1700s to really nail pi. But when we get it, we've got it. I hope this helps.